This is Mr. Wilford, and we are starting Chapter 5 here today. And I just wanted to go over Chapter 5, Section 1 with you. Perpendicular and angle bisectors. There's a few terms here in this section, and so I'll talk about those a little bit, as well as a couple of theorems. Um, First of all, one term here is something called equidistant. And it says when a point is the same distance from two or more objects, the point is said to be equidistant from the objects. And so basically we're talking about equal distances. And when we look at this first theorem, distance and perpendicular bisectors. Um, what's going to happen here is we're going to have a theorem, and then we're going to have its converse theorem. So the first part here talks about if a point is on the perpendicular bisector of a segment. So let me stop there for a second. And what is a perpendicular bisector? A perpendicular means we have segment AB, and then we're taking this line, and that's perpendicular 90 degrees to that segment. And it's a bisector, which means that it's cutting that segment right down the middle, right in half. So this side here is equal to that side there. So if a point is on that perpendicular bisector, then it is equidistant from the endpoints of the segment. So in other words, this distance here, a to x, is the same as b to x. Now the converse of this is kind of just flipped around. If a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of that segment. So now what we're saying is we have some point out here in space, and if we measure from that point to A and that point to B, and they're the same distance, what we can say then is that point must be on what we call that perpendicular bisector line. So it's kind of in reverse. Another term down here is something called a locus. A locus is a set of points that satisfies a given condition. So when we talk about any of these points on this line, we're actually talking about a locus, which means really just a bunch of points. Okay. Be sure to kind of look through some of these examples here as we go through. I don't have a whole lot of time to talk about those, but you can kind of read through those step by step. I want to get to this next theorem here. The distance and angle bisector. A couple theorems here again, and its converse. First of all, the angle bisector theorem. It says if a point is on the bisector of an angle, again, bisector meaning that we're cutting that angle in half. So this is our big angle, and we're cutting that angle right down the middle. Then it is equidistant from the sides of the angle. So in other words, we take a point C and we drop it down to both sides of that big angle. Those two sides are going to be the same, AC and BC. The converse then is if a point in the interior of an angle is equidistant from the sides of the angle, then it is on the bisector of the angle. So now we're measuring again from each side of the angle. We're measuring this distance and this distance, and we find out they're the same. Then that point C must be on that angle bisector. Okay, so another theorem and its converse. Again, we have some very good examples here, so make sure that you read through some of those. Some of these involve some algebra again. Parachute application. And finally, let's go to the last page here. This is a pretty good example here about writing equations of bisectors in the coordinate plane. Make sure you read through this. Basically what it involves, a couple of formulas here. The midpoint formula, so we're finding the midpoint. The slope formula, so we're using the slope formula here. Sorry, the change in the y's over change in the x's, as well as the point slope form of a line. So make sure you read through that, and please let me know if you have any questions. Thanks.